Hello, everyone, and welcome to another Dr. Spotfire monthly session. I'm your host, Boris, and today I'm joined by Amir Farati, who is a colleague of mine. I'm going to let him actually present to you himself.
Hello, Amir Farati, data scientist from Spotfire. Happy to be here and learn all about tips and tricks in Spotfire when it comes to geoanalytics.
Thank you, Amir. We have a very, very intriguing session today, so stay tuned. Let's first do some housekeeping. Before we start, let's have everyone on the same page. Let's define what Spotfire is. Spotfire is a visual data science platform. This means that it's not just a tool, but a platform that enables you to create low-code or no-code visual analytics applications to solve complex industry problems. The types of use cases that Spotfire addresses are not traditional BI problems. We have industry-specific solutions like custom visualizations for upstream energy, high-tech manufacturing, and life sciences, amongst other solutions. And so Spotfire is focused on visual data science that's meant to convey the interaction of real-time data connectivity and performance, visualizations, and advanced data science. Now that we define what Spotfire is, let's look into the Dr. Spotfire problem. What is it and why you should care about it? The program is designed to help the vast spectrum of Spotfire users from beginners to advanced. And the Dr. Spotfire office hours are our monthly sessions, and they're live the first Tuesday of every month, streaming live in YouTube and LinkedIn. So how does Dr. Spotfire work? Dr. Spotfire is a program aimed at helping, as I mentioned, new and advanced Spotfire users. It's hosted by Spotfire experts in data science and customer success. It consists of feature sessions like this one and quick tips. These quick tips are monthly. The quick tips and the monthly sessions are the core of Dr. Spotfire, but it's driven by our community through ideas portal, community, and social media, resulting in the Spotfire product evolving with new visuals, data functions, apps such as the Copilot, accelerators for real-time analytics and data connectors, as well as articles, white papers, and scripts to extend and enhance the Spotfire experience. And all that results into many, many more exciting things with Spotfire. Great. Now that you know what Spotfire is and what Dr. Spotfire is, I would like to kick off our presentation with our motto: learning is often fueled by questions. Questions spark curiosity, encourage exploration, and lead to a deeper understanding of a subject. So if you have questions throughout the session, please let them coming, and me and Amir will try to do our best to answer them all. A quick confidentiality disclaimer, and let's start with today's agenda. As I already mentioned, we'll be diving into geoanalytics in Spotfire. We'll start with a very quick intro into geoanalytics and map charts in Spotfire, and then we'll continue with the use case that we have prepared for you. And after that, Amir is going to demonstrate you how you can build such analysis from scratch using shapefiles and GeoJSONs. As we proceed with the presentation, again, feel free to ask any geoanalytics questions, and we will answer them. So with a quick start, let's define what geoanalytics is. Geoanalytics, or also called location analytics or geospatial analytics, simply refers to location-based analysis that gives geographical context to data. By incorporating geospatial data into analysis, a business can understand logistics, predict weather patterns, identify geological conditions, optimize routes, monitor workers in transport, and so much more. Another benefit is that maps are often easier for multiple users to understand than just charts and functions. So the way that we enable geoanalytics in Spotfire is through map charts. Map charts allow you to position your data in a context. They're commonly used in a geographical context, but they can also be used in a variety of other graphical contexts, such as positions of chips on a chip wafer in a semiconductor manufacturing, or machines and robots on a shop floor. Using a map chart allows users to visualize data within a set of known reference points and helps identify problem areas quickly. Layers in map chart are mainly categorized into two, a data layer and a reference layer, with the data layer comprising of marker layer and a feature layer, and a reference layer comprising of map layer and WMS layer and an image layer. And talking about layers, this is something that Amir is going to talk a bit more in a bit. But just as a quick overview, there are different layers in the map chart in Spotfire. A feature layer that contains features or shapes of polygon, line, or point. Feature can be used either as a data layer or as a reference layer, only displaying items or visual interest. A marker layer, markers or pies are positioned in the different areas, which can be used to interact with the map chart. A map layer that allows to display your data on a tile-based web map. There are always map layers are used as a reference layer and cannot be interacted directly. WMS layer is another type of reference background. It's retrieved from Web Map Space, a web standard for accessing geo-referenced map images from different geographic information system databases, or GIS. And an image layer, which is another way to set up a map chart and use the background image and then position markers on the pies on top of that image. Important thing is that with image layer, the data table must contain X and Y coordinates for the markers to be placed correctly in the geographical positions. And that was my very quick intro to map charts and layers, really the foundation of geoanalytics. And now I'm just going to have a very quick preview of our use case that we have created for you. So I have this very, very cool map of the state of Wisconsin. And all those blue markers are actually Wisconsin University campuses. And you might notice that I have added two cool features. One of them is the major roads for Wisconsin. As you can see, there are way more, we can see the road networks in the state of Wisconsin. And I have also separated the state with the transportation boundaries. Now, this is very easy to apply. That's what we're going to look at today, and we're going to look at different ways of doing it. It really can take 5 minutes if you know what you're doing, if you're having the correct data, obviously. And we're going to demonstrate the real power of Spotfire. And then here I'm just going to pass it to Amir. If you want to also, Amir, to add something to this analysis and then kick us off with the demonstration.
Sure. Thank you so much, Boris, for the introduction and preview of the analysis that we have prepared for today's session. As you mentioned, we are in a Spotfire. You can add all sorts of vector data, and vector data such as points, lines, and polygons. In the analysis that is presented on the screen, you can see the points as the UW campuses. Lines are the major roads in the state of Wisconsin, and polygons are the transportation regions. And all of these are interactive. You can click on them and interact with them. You can add labels, you can add pop-ups to them, and you can, for further analysis, you can add markings to them, and then mark your database of their location or some attribute that is common between all these layers that you have. So I'm going to show you how to create such map or visualization in a Spotfire from scratch, demonstrating the data types and extensions that we support. So Spotfire natively supports shapefiles, which is a commercial, very well-known extension for geospatial data. We support, Spotfire natively support GeoJSONs as well, another open source, very well-known, established extension for geospatial data. One cool feature about the Spotfire is if you import a table, a raw table with latitude and longitude in it, Spotfire automatically detects the latitude and longitude in your raw table, which is in, for example, which is in a spreadsheet, and then transform it into locational data. So in this example, we are going to see an example of each of these. We are going to see an example of a shapefile, we are going to see an example of a GeoJSON, and we are going to see an example of a raw data. So I'm going to share my screen and build this beautiful map from scratch together.
Great. And I already have quite a lot of questions for you, Amir.
Sure.
I'm sure that we're going to have from the audience too, and later on as well when people watch it. But I'm not going to interrupt you for now. I'm going to let you share your analysis.
Of course. Thank you. So here you can see the landing page of your Spotfire with no data whatsoever. So first thing that we're going to do is to browse to local file. And as you can see here, I have a shapefile, which is major roads in the state of Wisconsin. I have a GeoJSON, which is transportation regions in the state of Wisconsin. And I have a University of Wisconsin system campuses, which is an Excel worksheet. So I will add this to my data. So you can see that I have a campus name, and each campus name has a latitude and longitude in a raw format in a table. And I click OK.
I just want to ask you here a question, Amir. Sometimes maybe the columns are not going to be called longitude and latitude. Does that matter in the sense of what we're trying to do here?
So if your columns are not named latitude or longitude, then when you are trying to add your data to your map chart, you need to specify which column is corresponding to latitude and which column is corresponding to longitude. Some people, for example, call it lat and long. So in those cases, you need to do that yourself by specifying which column is representative of latitude and which column is representative of longitude. So as you can see, here is my data, raw data, campus name, latitude, and longitude. And if I come here and add a map chart to my dashboard, as you can see, it automatically detected the UW campuses and your locational data and visualized it. So if you go here to the properties of your layers, and in the positioning, you can see that it automatically detected that longitude is representative of longitude and latitude is representative of latitude. If you have columns that with other names, you can come here and specify right here that which column corresponds to X column or longitude. So now we have all of the UW campuses as points on our map chart. The next step would be to add our shapefile. So again, Spotfire natively supports shapefiles. And one quick tip here is that shape files, as you can see, this is a shapefile. Shapefiles are a group or set of files. So you have SHP, you have SHX, you have DBF, and you have PRG. In order for a shapefile to work appropriately and properly, you need to have all of your files together. So in a Spotfire, you only see the SHP file, but in the same folder, you need to have all other folders that are related to that shapefile as well. This is the case for all shapefiles. So I will click on the major roads as a shapefile and just click open. And then click OK.
And you add it as a separate data table, right?
Yes, I added it as a separate data table here. As you can see, I have major road here. I have University of Wisconsin system here. And then now I can go to the properties, go to the layers, and add a feature layer of major roads. And as you can see, my major roads are added to my map chart. So now I have UW campuses and all the major roads in the state of Wisconsin. The next step would be to add a GeoJSON. Again, Spotfire natively supports GeoJSON. So one difference between GeoJSON and shapefile is that GeoJSON is just a text file, and it's just a single file. And you just click or select your GeoJSON, click Open, add it as a new data table, click OK, and it has been parsed, processed by a Spotfire and added as a data table. So this is a region, which is a GeoJSON, as you can see, and it's already parsed and processed automatically by a Spotfire. And then again, you can come here to the properties, to layers, add a feature layer of the regions. And as you can see, you have all the regions now here. And in order to change the layout or priority of the layout, so you want major roads on top of regions, right? So you need to move that forward and then change the color of the region that you have to some base off of the region CD codes. And here you go. You have your 5 regions in the state of Wisconsin. You have all the lines as a major roads, and you have UW campuses. At the same time, you have 3 data types: lines, points, and polygons. You have GeoJSON, you have shapefile, and you have a raw table at the same time in a single map chart. And Spotfire detects all of them as a data table, and you can start doing your analysis, visualization, adding your visualization to your dashboard. And for further analysis, you can do markings, you can use data functions to run more advanced geoanalytics on your geospatial data.
That's great, Amir, and that's such a it's a very fast way of presenting and building a great geoanalytics analysis. But I wanted to ask you about the polygons. So can you elaborate for our audience? Would they be able to interact? For example, in this case, you have put major roads, very easier to understand what it means, and in the sense of the concept of a polygon. So can you explain how can you interact with them?
Okay, sure. So in basically vector data in geospatial analysis, you have points, you have lines, and you have polygons. So polygons, think of it as areas or regions. These are the polygons. And in terms of interaction, you can add a label, you can click on them and select a specific polygon, and then you can add markings, you can add also you can use data functions to run further analysis. For example, you want to know how many points do we have in each region. For example, here in the south east region of the state of Wisconsin, where Milwaukee is located, southeast, you have 3 UW campuses. And this is southwest region. So in the southwest region, so in southeast region, you have 3 UW campuses. So question here is that how many points are in each polygon? So you can use our data functions, geospatial data functions, to calculate the number of points in a polygon. But if you have a name of region in your UW campuses table, then you can add a marking. So when you select a region, all of the markings that are associated with that region will be selected. Then you know what are the campuses that are located inside that region. So with the use of either markings or data functions, you can run hundreds of analyses on your geospatial data.
That's great. It seems like you need another just 5 minutes to build all that. Getting the data function and just get it to work. And I have a follow-up question on that. Many people will be intrigued as well, maybe for the difference between shapefiles and GeoJSONs, and obviously we did with both here, but can you give any tips and tricks for anyone who is just about to start, or it's a proficient user in Spotfire but has never done a geoanalytics before and wants to get into it? What might be a bit easier to start with, or if they have in their organization only one or the other, can they swap between? Is there a way of converting and so on?
Sure. That's a very, very good question. So geospatial, what is the difference between raw data and geospatial data? The geospatial elements. So when you have a geospatial data, your data is located or has a location associated with it. So then there are some protocols to store geospatial data. So two of the most famous protocols for storing geospatial data are shapefiles and GeoJSONs. So shapefiles was designed by a company called Esri, and then everybody else picked up on it, and now it's a very well-known, well-established extension or protocol for storing geospatial data. And GeoJSON is more open source, and it's based off of the JSON protocol to store locational data. So the main difference here is that when you are working with shapefiles, you need to have 4 files at least for your shapefiles to run or to be able to store your data properly. You have SHP, you have SHX, you have DBF, and you have PRJ. And each of these different files are responsible for storing a set of criteria or set of characteristics of your data. What is the projection system? What is the database type? What is the main protocol? And what is your locational data? However, when you are dealing with GeoJSON, you're only having one data, which is TXT or text file. So it provides a lot of leverage for compression and easier to work with. However, not all softwares or platforms support GeoJSON. So shapefile is more well established. So when you are working with like across platforms, it might be easier to be working with shapefiles. However, both of them provide very, very robust, efficient way for storing your geospatial data. And fortunately, Spotfire natively supports both of them. So whether you have a shapefile or a GeoJSON, you're good in a Spotfire, and a Spotfire detects it, automatically supports it, and you can add it to your map chart and start running your sophisticated analysis on it.
That's great. And obviously here we've added 2 extra feature layers to our map and our analysis. What if we had, that means that there's no limitation for Spotfire to add shapefiles and GeoJSONs on top of each other, right?
Exactly. So you can have, so one thing that geospatial analysts and GIS analysts love to do is to put layers on top of each other and have a map with hundreds of layers, and each layer represents something. So power lines, you have a road map, you have power lines, you have your regions, you have your jurisdictions, you have estate lines, you have water bodies, you have location of your wells, you have location of your features. So each of these are different layers that you have in your map. And these layers can come from different extensions. You can have a group of your layers stored in GeoJSON. You can have a group of them in shapefiles, and Spotfire natively supports them, transform them into data tables inside the Spotfire, and you can seamlessly and efficiently work with hundreds of layers, and there is no cap or limit on number of layers that you can have in a map, or and also data types. You can have points, lines, and polygons on top of each other, as you can see in this map inside the Spotfire.
That's great. That's perfect. And one important thing, I guess, is from my experience working with with Geoanalytics, I guess, is the reference system, right?
Mm-hmm. Yes.
So if we have a look here at our visualization properties, and maybe let's open one of the feature layer settings. We can see the coordinate reference system. So can you explain for the audience what will happen in case they get their shapefile or GeoJSON file and things don't get to the correct place? What they can do about it? I guess this is more of a debugging type of question.
Of course. So Earth, our planet Earth, is not a perfect sphere. And as it is not perfect a sphere, we have different projection systems. These projection systems are a way to project points, lines, or polygons on the surface of Earth to a map. So our Earth is 3D, but the map that we are seeing is 2D. So we need projection systems to project a 3D object like our planet Earth to a 2D object like a map, as we can see. And we have hundreds or thousands of projection systems all across the world, and each organization has its own. Governments have developed their national or local or statewide projection systems. And as you can see in the layer that you brought up, we have a projection system that is local to a state of Wisconsin. So when you add your layers and you see that there is a misalignment or mismatch between the locations, or for example, you added the state of Wisconsin, but it's not exactly located on the state of Wisconsin, it can be due to the mismatch of your projection systems. So it's always good to have a unified projection system, or have all of your data in a single unified projection system, so you can run your analysis more efficiently without the headache of transforming all of your data and geospatial data into different projection systems.
Great, thank you, Amir. That was very, very explicit answer. And because we are almost at time, we have 2 questions from the audience. So one of them is, are those files going to be available for download? We can certainly have a community article where you can find this data set and practice on your own, and create the same or even better map. And then we have another question from LinkedIn. Can we connect to ARCGIS database instead of export the shapefile from it? I'm going to leave that for Amir, if you can have that.
Yes. So that's a great question. And so currently in the current version, we need to, as you mentioned, export shapefiles and then import it into a Spotfire. However, we are in the process of creating a custom connector for ArcGIS product, so you can connect to geodatabases in ArcGIS or ArcGIS itself, and then let the Spotfire and ArcGIS and Esri products communicate with each other. We're in the process of development of that connector, database connector, and in a near future, we are going to release that connector.
Perfect. Thank you, Amir. All right, we are at time. I'm just going to wrap it up with my last 2-3 slides. So please subscribe for the recorded session if you have missed the live. If not, we are live every first Tuesday of the month. Just search for Dr. Spotfire on YouTube, or go directly to youtube.com/@Dr. Spotfire. You will be able to see this session recorded. We are also live on LinkedIn, so don't forget that. Contact us to share your work or suggest anything. As we mentioned at the beginning, we take a lot of inspirations from you guys, so feel free to share your work or ideas for any other quick tips or Dr. Spotfire sessions. And yeah, I think that's pretty much it. Thank you very much for joining. I will see you in the next Dr. Spotfire session. And thank you, Amir, as well, for joining this session. It was great having you.
First, thank you so much.
Great. Thank you, everyone. Bye-bye.